sum of numbers, or sum of terms. So like here when it says S sub 100, that means find the partial sum of the first 100 terms. And this is for the series a sub n equals to n. In other words, as you know, the natural numbers, 1, 2, 3, 4. That's the series, and we're going to add up the numbers from 1 to 100 in one fell swoop. So back in the day, there was this kid. He was an elementary child, and the teacher got tired of redirecting him over and over and over and over again. So she set up, add the numbers from 1 to 100, and he did it in like 7 seconds. And that's what we're learning today. So let's think about the first 10 terms. Let's just find S sub 10 first. So S sub 10 would be 1 plus 2 plus 3 plus 4 plus 5 plus 6, etc. And like you guys could add that on the calculator, and it's fine and whatever. But the trick is we're going to add this twice, but I'm going to reverse the order. In other words, I'm going to write S sub 10 down again, the first sum, but I'm going to write 10 plus 9 plus 8, and so on. Now I'm going to add all of these together, right? So 10 plus 1 is 11, 9 plus 2 is 11, 8 plus 3 is 11. Do it, do it, do it. And the idea is I could do it straight from here. For example, how many 11 do you have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 11s. And let's see, how many times did I add S sub 10? Well, I added it twice, so I have 2 of these. Look, this guy right here is just like an X or a Y, just something. So what we're really saying is that I have 2 S sub 10s, and that's equal to, how many times did I add 11? I added 11 10 times. So now all I need to do is divide by 2, and there I have it, the 10th partial sum, which is 11 times 10 divided by 2 is 5, so 55. Take that same technique and now do it with the first 100 numbers. So write this out and then do this on your own. Remember, the idea is I'm going to add this twice and then essentially divide by 2. And remember, I'm writing in reverse order, like that. Get as far as you can get and then press play again. And so the question again is, how many times did I add 101? And it's always going to be this number, right? It's going to be 100. So I have 2 times S sub 100, 2 times the sum is equal to 101 times, I added these 100 times. And now all I have to do is divide by 2, and I've got it. Now keep in mind, this pattern works for the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But we want to use the same idea and find the pattern for any type of, and what kind of sequence is this? Yeah, there's a common difference of 1, so it's arithmetic. We want to find the pattern for any arithmetic sequence. Write down your thoughts. Not about it yet. So try to connect these terms to this end pattern and to that end pattern. Keep trying, and then you can uncover by pressing play. So each time it's the first term, like 1 plus 100, or in the previous example, 1 plus 10, right? That would make 11. 1 plus 100 would make 101. So it's 1 plus 100, or 1 plus 10, depending on our example. And then it's times the number of terms, right? How many terms do we have here? We had 100, so that's where that 100 comes from. Over here we had 10, that's where that 10 comes from. And then lastly, each time we divided it by 2. So let's write this out. How can I write the first term? Well, I can write the first term as a sub 1. So first term is a sub 1. The last term I can write as a sub n, right? The nth term. How many terms would there be? Well, if I'm talking about a sub n, there would be n terms. And then I just have to do that last step divided by 2. And that's, sorry, s sub n. That's the sum of the first n terms of an arithmetic sequence. You should write that text down, and then you're done with this video.